right, we're going to look at systems of equations for just another second. We have three ways that we can solve systems of equations. We can use the elimination method. That is the adding method. Add them together. It's called the elimination method because through the process of adding, you're going to eliminate one of your variables. That's the first method. The second method is the substitution method. Substitution. The substitution method. And that's when you solve one and then you plug in the other one. We'll do some examples of it so you'll see. And the third way to solve a system of equation is the graphing method. Now, I will tell you that this one gets a star. Why does it get a star? Well, there's two reasons that it gets a star. The first reason is because it is markedly inaccurate. Inaccurate. If you are trying to land a spaceship on the moon, you do not use the graphing method because it is far too dependent on how well you draw your graph. And that is not a good technique to use when you're doing something like landing a spaceship. So it is inaccurate. However, it can be very fast. And this is nice because when you are taking standardized tests like the ACT and the SAT, many times you can graph a quick solution and you can get an answer much faster than actually solving for X and Y. So we're going to do an example 3 different ways so that you can see what's happening. So here are the two equations I have. I have X plus Y equals 3, and I have 2X minus Y equals 0. Those are the two equations that we are going to use, and we are going to solve it all 3 ways. 1, 2, 3. So our first way that we're going to solve it is by elimination. And this is the method that we worked on in last chapter. We have X plus Y equals 3 and 2X minus Y equals 0. The Y's are going to cancel out so that we can say that 3X equals 3, so X equals 1, right? That's the solution to this. Then if we go back and we say 1 plus Y equals 3, we know that Y is going to equal 2. Okay, I know I rushed through this kind of quickly, but we did this last chapter. This is nothing different than what we have done before. Let's look at the second way we could solve this. If we had, different color, hold on just a second, here we go. If we had X plus Y equals 3, and we have 2X minus Y equals 0. One thing that we could do is we could switch around this X and Y so that X equals 3 minus Y. Does that make sense? I'm going to subtract Y from this side and subtract Y from the other side. Just moving that over there. So then once I know that, instead of using X in this second formula, I can use 3 minus Y. So it would be 2 times 3 minus Y equals 0. I just copied this equation down, the 2X minus Y equals 0, but instead of the X, I put in this. Okay? So then that's 6 minus 2Y minus Y equals 0. 6 minus 3Y, 2Y minus another Y, is 3Y equals 0. Subtract 6 from either side. Negative 3Y equals negative 6. Divide by negative 3. And we get Y equals 2, which is the exact same thing that we got there. And if we take this and look at our first equation, if Y is 2, then X has to be 1, right? Okay. Exact same answer as here, but a different way to approach it. All right, so now let's look at our last way to do things, and that is the graphing method. So for the graphing method, I'm going to draw a little graph, and I'm going to start with x plus y equals 3. I'm going to graph that. And again, I know these are lines, so if x is 0, what is y? 3. Okay, if x is 2, what is y? 1. All right, so my first line that I have to draw is at 0, 3, and 2, 1. One, 2, 3, 4, 5, and this is 2, 1, 3. Okay, and then my second equation is 2x minus y equals 0. So again, if I have an equation, x and y, and I have x equals 0, then what is y going to equal? Well, it's 0 minus what equals 0? 0 minus 0 equals 0. All right, let's do x equals 2. 4 minus what equals 0? 4 minus 4 equals 0. So, plotting this line, which I will do in a different color, 0, 0, and 2, 4. 1, 2, 3, 4. So here is my second line. What I am looking for is I am looking for this, my point of intersection, and I want to know what this equals. And so I draw a line down here, and that looks like my x is about a 1. And I draw a line over here, and it looks like my y is about a 2. So I'm going to say that point 1, 2 is the solution to both of these equations. And look at, it's exactly the same as over here. X equals 1, y equals 2. You can see, however, how easy it would be for this to get messed up if I did not draw my graph very well. It helps when you're using small numbers, and it helps if you, are not too sleepy and you can draw your line straight. So these are the 3 different ways that you can solve a system of equations. In this chapter, Fred will say, use the elimination method, or use the graphing method, or use the substitution method. He's telling you that because he wants you to practice all those different approaches. In real life, however, though, no one cares how you get the right answer. They just want you to get the right answer. The graphing method will become in very handy again when you take these standardized tests. The other 2 methods are much faster for solving problems in your math book. Okay, good luck. You can do it.